Hi, in this video we will learn how to write equations for lines in higher dimensions in our M spaces. Well, like the R2 and R3 case, every line can be determined by a point, while point in our M will have M component and a parallel vector. We write V. The forms that we are going to write here are going to be exactly same as before. In other words, we have two forms are called a point parallel form, which basically is P xt equals to P, the vector form of P plus TV. And again, the difference between these and R2 and R3 is only the number of components. In other words, X will have 1, 2, up to M components equals to P will have 1, 2, up to M components, and V will have also M components. How about the other form, which was the parametric one? Metric form. Well, parametric form is also the same. So basically, you write every component, equation for every component separately. So x1 is going to be p1 plus tv1. x2 is going to be p2 plus tv2. x3 equals to p3 plus tv3, and this continues up to mth component. So we have M equation. Well, also we learned that there was another form that it was given by 2 points. Also, if 2 points P and Q on the line are known, we have this third form, very similar to R2 and R3. It's called 2-point form, yes. Which was what? So in that case, again, we have xt equals to 1 minus t p plus t times q. This vector equation is exactly the same thing, but when you write down the components, it will show its difference, that our points in M space have P component, M components, sorry, and vectors will have M components. So again, in general, for Rm, for every line, we have these 3 forms. Actually, we can do one example before we move to the next topic. Okay, example. Find all 3 forms of equation for the line in R4 which has 2 points 1, negative 1, 0, 2, and 3, 1, 2, and negative. Well, okay, this is nice. 2 points are given. Let's call this one P and this one Q. Then we can write 2-point form right away. 2-point form, which is xt equals to 1 minus t times p plus tq, and this is, well, we can write x1, x2, x3, x4, or just simply for this one you can just write xt equals to 1 minus t times p, which is this, plus t times q, which is 3, 1, 2, and negative. Very nice. But when you have 2 points, remember always that since P and Q are 2 points on the line, hence, as a result, the directed line segment PQ is parallel, is on the line, and as a result, the vector Q minus P, turn the points to the vectors. The vector Q endpoint minus start point is parallel to the line. Okay, so it means what? It means that we have V here. 3, 1, 2, negative 1, minus 1, and negative 1, 0, 2, which together gives us 3 minus 1, 2, 1 minus negative 1, 2, 2 minus 0, 2, and negative 1 minus 2 is negative 3. Well, now we have a point. Pick one of them, P. So then we can write point parallel form, which is xt equals to P plus TV. Well, in this case, xt is equal to P is 1, negative 1, 0, 2, plus T, V is 2, 2, 2, negative 3. And in the case of the parametric equation, parametric form, what we have is that, well, write x1, x2, x3, x4. This is equal to corresponding component from P plus T times the corresponding component from V. Well, let me just simplify this. x1 is 2t plus 1, x2 is 2t minus 1, x3 is 2t, and x4 is negative 3t plus 2. Well, just summary, in Rm we also have equation for lines in all 3 forms. When we have 1 point and a parallel vector known, we have 2 forms, and then when 2 points on the line is known, we have another form, 2-point